Welcome back to the series of videos on hyperbolic functions. In the previous video, we established the following identities: cos square theta minus sin square theta is equal to 1, and 1 minus tan square theta is equal to sec square theta. And then hyperbolic cot theta, hyperbolic cot square theta minus hyperbolic cosec square theta is also equal to 1. In this video, we are going to use the exponential function definition of the hyperbolic functions to check whether these identities are indeed the same. We are doing this so that we can consolidate these identities as the lesson progresses. Remember, these three identities are the fundamental identities and can be used to obtain other identities. Sin s, or hyperbolic sin x, is defined as e power x minus e power negative x over 2, and hyperbolic cos s is supposed to be cos s no square. It's also defined as e power x plus e power negative x over 2. What we are going to do is to substitute these exponential functions into the first identity. The first identity is sin square x minus cos square x cos square x minus sin square x should give us 1. So we are going to throw these guys into this, replace them with the cos and the sin to see whether we will get 1. So cos square x will be e exponent x plus e exponent minus x all over 2 squared, then minus the sin square x, that is e exponent x minus e exponent negative x all over 2 squared. We know the square will affect the numerator and the denominator. So for this side, we are going to have the denominator will become 4, but the numerator will be e to the power 2x plus 2 e to the power x multiplying e to the power minus x plus e to the power minus 2x. Then for the sine, we are going to have e to the power 2x minus e to the power 2 multiplying e to the power x times e to the power minus x plus e to the power minus 2x all over 4. We can simplify this to have for the left hand side, we are going to have e to the power 2x. Since e power x times e power minus x become 1, here will become 2, and then e to the power minus 2x all over 4. And the right hand side will become e power 2x minus 2 plus e power minus 2x all over 4. Since the denominators are the same, we can actually subtract the exponent. So e power 2x will take care of e power 2x. And then e power minus 2x, when they subtract, it will go off. Then we'll be left with 2 minus negative 2 all over 4. And 2 minus negative 2, it becomes 4 over 4. And this will turn into 1. So this proves that sine square cos square x minus sine square x is indeed 1. Let's go to the next identity. The next identity is 1 minus tan square x is equal to sec square x. So let's write that here. 1 minus tan square x is equal to sec square x. And we know tan x is e power x minus e power negative x over e power x plus e power negative x. And sec x is just the reciprocal of cos. So that will be 2 over e power x plus e power negative x. So we are going to simplify this, as throw these guys into this equation and see whether we'll get the right hand side. So 1 minus tan square x. We'll put in the exponential function to be e power x minus e power negative x all over e power x plus e power negative x all squared. This becomes e power x. Let's square the top. E power positive 2x minus 2 e power x multiplying e power minus x plus e power negative 2x all over e power x plus e power minus x all squared. Remember, the square is affecting the top and down. I have decided just to expand only the numerator to make the subtraction here very simple. So here the LCM is 1. The denominator here is 1. So our LCM becomes e power x plus e power minus x squared. So this side becomes e power x plus e power minus x squared minus the whole of the numerator here, e power 2x minus e2. Let's just simplify this because those two guys will cancel each other. The e power x will cancel e power minus x. So minus 2, then plus e power minus 2x. Since we are familiar with the expansion, we'll expand the right hand side of the numerator. Let's do that here. This will be e power 2x plus 2, then plus e power minus 2x, then minus e power 2x minus 2. Now it become plus 2. I'm actually distributing the negative sign to the bracket. Then minus e power negative 2x all over e power x plus e power minus x squared. Simplifying, we are going to have the e power 2x taking care of this. the e power minus 2x also taking care of this one. The simplified expression becomes 4 over e power x plus e power minus x all squared. Now, when we square sec x, we are going to get the same thing. When we square the expression e power 2 over e power x, and when we find the square of this e power 2 over e, let's actually do it on a different page so that you can see it very clearly. Sec is equal to sec x is equal to 2 over e power x plus e power minus x all squared. Sorry. So that's sec s. So if we want to find sec square x, we are actually going to square both sides. We are going to square both sides. So this side squared, excuse me, let me use a different color. This side squared is equal to this side squared. So this becomes sec square x equal, the top becomes 4 over e power x plus e power negative x all squared. And it's exactly the same thing as we had here. So this implied the identity 1 minus tan square x is actually indeed equal to sec square x. Let's pick the last identity, which says cot square x, cot theta minus the hyperbolic cosecant square theta is equal to 1. Now, cot s is defined as e to the power x plus e negative x over e power x minus e power negative x. The hyperbolic cot x is just the reciprocal of the hyperbolic tan x. And then hyperbolic cosecant of x is 2 over e power x minus e power x power negative x. This is also the reciprocal of the hyperbolic sign. So, and the identity is cot square x minus cosec square x should give us 1. So let's throw in these guys and square them and check whether the difference between them will actually be 1. So we are going to have e power x plus e power minus x all over e power x minus e power negative x all squared minus 2 over e power x minus e power negative x all squared. The numerator here becomes e power 2x plus 2 is the same expansion that we've been doing. So I'm writing the expression straight away. Plus e power negative x. Then let's just write e power x minus e power minus x all squared. Then this side becomes 4 e power x minus e power minus x all squared. The LCM The LCM is the same thing. So we are going to pick e power x minus e power minus x all squared. Then we are going to have e power 2x plus 2 plus e power negative x minus 4. This becomes e power 2x minus 2 plus e power minus 2x. Here should have been 2x, the expansion here. 2x all over e power x minus e power minus x all squared. When we expand the bottom, if you are following the video very keenly, if you expand the bottom, you are going to get the same thing as the numerator. So this implies the whole fraction will translate to 1. And indeed, it has proven that cot square x minus the hyperbolic cosecant square x is equal to 1. Thank you for watching. In the next video that follows, we are going to now use these basic identities that we have learned to establish other identities. Thank you.